Hey, welcome back. The Cosmic Mistress has arrived. I know it's been a minute, and I will say that really the only thing that has happened was that I got a gong, and that I wasn't talking on some Mary Jane, and I took a toke. Here we are. I'm looking at me, looking at you. And I got my makeup done. And I figured if someone did my makeup today, I should probably get it out there, let it be seen. So here we are. So great to see you again. We're going to read. Cosmic Mistress is back, and we are going to read Quadrivium. Do you remember? It's been a minute. The four classical liberal arts of Quadrivium: number, geometry, music, and cosmology. What I may be reading may be a slight repeat. I think that's okay. I think now I'm looking at shapes and I'm like, did we already? How far did we get? I should look, but I just don't. I care, but I don't care. Okay, we're going to get into it. Right where I decided to pick up, because I feel like if it is a repeat, it's worth exploring again. You know? The canon, 3, 7, and 11. The squaring of the circle, as in 3, 11, is coded in a door at the Jerum Church in Gotland, Sweden. Opposite in parentheses. Irish and Norse myths abound with tales of 33 warriors, 3 times 11, parentheses, not comma. The sun takes 33 years for a perfect repeat sun on the horizon. Jesus dies and is resurrected, age 33. Ramadan occurs every 12 moons, and it takes 33 years to move around the calendar. Halfway between 3 and 11 is 7, and it is an old secret that Earth's tilt, often hidden in a sacred art as the tilt of the holy head, parenthesis, the Virgin Mary's or the Buddha's, parenthesis, is the diagonal of a rectangle 3 wide, 7 high. Importantly, 11 /7, like a fraction, is the ancient Egyptian value for half of pi. So a circle radius r has the quadrant arc 11, 7r. The sand reckoner's diagram opposite is showing the page, is probably the examples. Got it. The sand reckoner's diagram opposite on the other page is a unique way of dividing a rectangle's edge to the canonical fractions, parenthesis, after Malcolm Stewart, parenthesis. A circle and a square can also be married by having the same area, and a double rainbow with bows at 41.5 degrees and 25.5 degrees precisely draws this below from Martineau, parenthesis, a marriage of heaven and earth indeed. So if you've ever been lucky enough to see the double rainbow, which we see here, so they're saying this is like the circle in the square, and it's mirroring the heaven and the earth, and the bows are at 41.5 degrees and 52.5 degrees. Okay, and then this is like the canonical, as in a shape of like a cannon, I assume, is in that church little entranceway, right? Those archways. And now these are the diagrams. I guess they're showing us. So this is the 1/3, 1/3, 1/3, right? We know what a third of a square is. This is the quarter. So there it is, quartered. Quartered, quartered. Also lots of triangles in there. And then that's the 1/5. And so they're showing all the different slices of it. Now, the fine print says above and below. We've heard it all before. The sand reckoner's diagram simply by joining corners to the centers of sides. A square's edge may be exactly divided into 3, 4, 5, and above 7 and 11 equal parts, which makes it extremely useful device. The initial lines also produce a plethora of whole number lengths, areas, shapes, including a multitude of Pythagorean 3, 4, 5 triangles at various scales. Okay. The sand reckoner's diagram. So it's capitalized. So sand reckoner's famous, something we need to know. Take note of that, please. And now just repeat, it takes the sun 33 years for a perfect repeat sunrise on the horizon. Jesus dies and is resurrected at 33. Ramadan occurs every 12 moons, and it takes 33 years to move around the calendar. This is some deep stuff. So just let it wash over you if you're not understanding it, and things will start to show up where you're going to be able to start to integrate this stuff. Pyramid, pi, a marriage of everything. The pyramid, right? The triangle, as above, so below. This is why I wanted to read this, because we hear these, as above, so below, but then to understand it at this technical, mathematical level or cosmology, so cosmologic, in this cosmologic way, is just going to really integrate it, where that knowing is going to be solidified in your intelligence. There is perhaps no more famous geometric object on earth than the Great Pyramid at Giza, Egypt, with its strange passages and enigmatic chambers. The 5 diagrams opposite show: 1. The square of the height is equal to the area of each face. So the square of the height is equal to the area of each face, which also is, I'm going to say 4. Yes, okay. And then a map of the earth, square of height equals the area of face. Okay. The golden section in the pyramid, shape, I don't quite understand. It kind of looks like a horizontal oval with maybe it's the omega. Equals 1.618. We can see page 86, which is 6 pages away. The golden section. So that's the golden section in the pyramid. The cosine of slope equals 0.618. Okay. Still reading. Pi in the pyramid, pi, or the symbol pi, defines the ratio between a circle's circumference and its diameter, 3.14159. The pyramid squaring the circle, see page 76, a pentagon defining a net for the pyramid cut and fold. Okay. So Origami shit. Geometry means earth measure. The pyramid functions as a ridiculously accurate sundial, star observatory, land surveying tool, and repository for weights and measure standards. Written into the design are highly accurate measurements of Earth, detailed astronomical data, and 3 simple geometric lessons. A 3-4-5 triangle fits the shape of the king's chamber, see below, and also gives the angle of the slope and the second pyramid at Giza. Halfway between the 2 slopes is 51.4 degrees, 1/7 of a circle. So this is the king's chamber. Those are the 51.4 degrees slope. Just let it wash over. Okay, so then, the pi in the pyramid perimeter is 2 pi height. There's that one. The circumference of the circle on height equals perimeter of pyramid base. Boom, boom. Constructing the pyramid from a pentagram, drawing in a circle. Okay? Okay. We're doing lovely here. Halflings and thirdlings. Sounds like birdlings. Defined by triangles and squares. An equilateral triangle, look to the opposite top left, or 2 nested squares, opposite top right. Both do the same thing. The circle inside each of these figures is exactly half the size of its surrounding circle. This is the geometrical image of the musical octave, where string length or frequency is halved or doubled. Approximately the 3-dimensional equivalent of the triangle, the tetrahedron, defines the next fractional proportion 1/3 as the ratio of the radius of the innermost sphere to that of its containing sphere. Look at the opposite bottom left. 2 nested cubes or 2 nested octahedra or octahedron nested in a cube, bottom right, all produce 1/3 too. The geometric third is musically equal to an octave plus a 5th harmonic notation. Thus, 2 dimensions quickly define a half and 3 dimensions in a third. A close but not perfect marriage is between 5 and 8. Those geometries often play with one another. In both these diagrams, the inner circle could be the size or orbit of the planet Mercury if the outer circle is taken as being the size or orbit of Earth. Okay. So this is the 5 and 8 that aren't doing the complete harmonizing, such as a triangulum and an equilateral triangle defines 2 circles 1/2 the size of the other. Add quadratrom, 2 nested squares define 2 circles, again 1/2 the size of the other. The add tetratron, the sphere inside the tetrahedron is 1/3 of the size of the sphere outside, and the add cubocatum, a cube and octahedron again defined in sphere 1/3 of the out sphere. I've never read these words before, so deepest apologies. The shapes of sound. Right? The shapes of sound. Now I'm getting warm. I was cold and now I'm like, oh, it's warm now. So the shapes of sound and 3/4. Geometry is number in space. Music is number in time. Geometry is number in space. Music is number in time. As well as we shall see in book 5, basic musical intervals are simply elementary ratios: 1-to-1 in unison, 2-to-1 the octave, 3-to-2 the fifth, 4-to-3 the fourth, and so on. Does that make sense? 1-to-1 the unison, 2-to-1 the octave. Okay, I know octave is 8, right? 3-to-2 the fifth, those numbers added together, 4-3 the fourth, and so on. The difference between the fourth and the fifth, which works out at 9/8, is the value of one tone. Musical intervals, like geometrical proportions, always involve 2 elements in relationship: 2 string lengths, 2 period lengths of time, or 2 frequencies, beats per length of time. Simple ratio sounds and look beautiful. We can see the musical intervals as shapes by swinging a pen in a circle at one frequency and a table in the opposite circle at another frequency. The device being called a harmonograph, shown opposite, are 2 patterns from near perfect intervals. The octave, the upper, draws as a triangular shape, the fifth, the lower, a pentagonal form. In the spirit of the previous page, 2 octaves or quarters can be exactly defined by 2 triangles, 4 squares, or intriguingly by a pentagon in a pentagram. So this is the octave, that's the fifth, and then these are the in pentagon and the pentagrams. Sexy stuff, yeah? Yeah, we're sexy. Yeah. Okay. I'm going to take a break there because that's an 18-minute video. And I'm going to come back for more, but we're going to start with the golden section and other important roots. And I'm going to get a little more comfortable.